Hello students, welcome to chemistry class. Today we're going to be talking about chemical calculations. We're going to be looking at various calculations we have under chemical processes. And don't forget, my name is Oilami today. And as well, I would like to remind you of our normal procedure to be at the right place, free of distraction and noises. And also, you must have with you your notebook, your pen, as well as textbook. Okay, so I believe we're going to make this class as interactive as possible. Okay, so over to our objectives. This class, I'll kind of divide it into two. The part one will be taken this week, and the next class will be for the part two. So for the objectives now, these are the things you ought to understand at the end of this class. The first thing is that you must know how to calculate the relative atomic mass. You must know how to calculate reacting masses. Underneath we have like 4 or 5 subheading, and same thing with calculating moles. So this is the week 2. The second class has to do with objectives, has to do with calculating formulae, as well as moles and chemical equation. Those are the things we are going to be looking at the coming class. So to start with the part 1 class, we look at the relative atomic mass. Okay, when we look at the periodic table as a whole, there are 117 different elements known. Okay, and also they all differ in mass because of different number of proton, neutron and electron they contain. You know, that's the reason for their different kind of mass that they have, due to these three: the number of proton, neutron and electrons. Okay, so the another point we're going to look at is that the actual mass of one atom is very small. Okay, when you say the actual mass of one atom is very small, when you know our previous class we talked about atom, and you know how tiny and small the atom is. So that's why a scale called the relative atom mass scale is used, the same as your relative atomic mass figure. That's why you can have those kind of figure. So where atom of carbon is given relative atomic mass of, you can represent the relative atomic mass with AR. Okay, is 12.00. That's the relative atomic mass of carbon. That's carbon 12. As some textbook will write it for you as C12. Okay, C12, that's carbon 12. Then all other atoms are given a relative atomic mass compared to that of carbon. So carbon is the relative element that they use as the relative point for other. Okay, when you look at this scale I drew here, we have hydrogen to be 1, we have carbon to be 12. When you look, the difference between hydrogen and carbon is that a hydrogen atom is 1/12 of mass of carbon atom. Can you see that? Since carbon is 12, hydrogen is 1, so it's like 1/12 of carbon. And if you look to the right hand side, which is magnesium, here we have magnesium to be 24, and that's twice of carbon mass that you have for magnesium. Same thing with sulfur, which is 32, calcium, which is 40. So reacting mass, we talk about reacting mass, and one thing about relative atomic mass, you can find that in your periodic table. It's written there for all the elements. Okay, reacting masses. Chemists often need to be able to show the relative masses of atoms involved in a chemical process. For example, what mass of carbon dioxide will be produced if 6 grams of carbon was completely combusted. When you say something is completely combusted, that means is burnt. Okay, completely burnt. If between don't forget, between we have the question say what mass, so we have to calculate mass of what carbon dioxide will be produced if 6 grams of carbon, that means 6 grams of this, is completely what burnt or completely combusted in oxygen. Okay, they won't tell you in oxygen. Definitely when you have something burning, that is in presence of what? Oxygen. So when you put C plus O2, don't forget our oxygen is diatomic. That means it has 2 atoms in its molecule. So we have it here, C plus O2 will give us CO2, which is your carbon dioxide. If you look at this, is it a complete equation? Yes, it is. Because I can still remember I told you on the writing and balancing of equation, oftentimes the equation being given you in question might not be balanced. So you have to take your time to balance before you proceed with your calculation. So note here, we are not really interested in phase or symbol state symbols here because we are dealing with what? The stoichiometry of the reactant and products in the chemical reaction or equation. What stoichiometry means is that we just want to know the quantity, we want to calculate the quantity being used. So we might not really be interested in putting it like this, solid. You know how we do it. Put solid here, as well as putting gas here, gas phase and all that. And here you now put gas again. But we are not interested in all that this time around. All we are interested in is calculation. So in this kind of, all these phase symbols are not really important. So instead of using the actual mass of atom, we use the relative atomic mass to answer this type of question. The actual mass is something given to you here. But instead of using it, we use relative atomic mass. And how can you do that? How can you calculate that? So we can work out relative formula mass of molecules such as oxygen and carbon dioxide using what? Relative atomic mass of the atom they are made from. For instance, when we are talking of relative formula mass, don't forget it has to do with compound, okay, or molecule. Since we have O2, that means 2 oxygen, we have to calculate the relative formula mass, and we have CO2, we have to calculate what? The relative formula mass of carbon dioxide too. And how can we do that? We can only do that using their relative atomic masses of each atom they contain. Okay, for instance, oxygen gas contains 2 atoms of oxygen. Okay, this is what I do right here. So I have O2 as a relative formula mass of what? That's 2 times 16. Our oxygen any day, anytime has relative atomic mass of 16. Okay, so the relative formula mass is the sum of relative atomic masses of all elements shown in the formula. For formula of O2 now, you have the relative atomic mass of oxygen to be 16, so you have to multiply it with the subscripts. So that means 2 times 16, giving you 32. Same thing with CO2, we have carbon to be 12 plus the whole 2 here. That means we have 2 atoms of oxygen, 2 times 16 too. So you now multiply this, that will be 32 plus 12 will give you 44. Okay, we can answer as C, carbon completely being bonds in oxygen to give carbon 4 oxide, and carbon 12, oxygen gas 32, and carbon 4 oxide gives what? 44. So if you put it this way, this relative mass of those compounds, but when you put grams, that means the above calculation shows that if 12 grams of carbon were completely burned, then 44 of carbon 4 oxide gas will be formed. This is what it means. 12 of these, if it's completely burned, okay, that means 44 grams of carbon 4 oxide gas will be formed. So 6 grams, how can you now do 6 grams? It's like you can use your cross multiplication, or what do you call it? You know, 12 grams of carbon gives you 44. Sorry about that. Okay, gives you 44 grams of CO2. Definitely, your 1 gram will give you what? 1 gram of carbon will give you, that will give you 44 divided by 12. 44 grams, or divided by 12. Then when you're now talking of 6 grams again, you now have to do 6 grams. We give you what? It gives you something like 44 divided by 12. It's becoming messy. Divided by 12 times 6. Hey, please, you got what I'm trying to bring out here. So if you do your answer, if you do your crossing and all that, the answer is to give you will be 22. Okay, just 6 here 1, 6 here 2, and 2 here will be 22. That's why it gives you, so 6 grams of what's it called, your carbon will gives you, it will give you 22 grams of CO2. I hope that's clear about that. Then we move to the next one. So I want you to try this. What mass of hydrogen gas will be produced if 46 grams of sodium was reacted with water? This sodium, this water reacting together, giving you sodium hydroxide, and hydrogen gas is being liberated. Okay, the first thing I ask you to be doing is to look at the equation. You have to balance it. If it's not balanced, you have to make sure the number of atoms or elements in the left hand side is equal to the one at the right hand side. But note, you can't change the subscripts. You can't change the subscripts. You can only put integers here and there. Okay, so I said tips. First, you must balance the equation. That's the first thing you must do. The next step is that you find the relative atomic mass of sodium. You can get that from your periodic table. By now you should know sodium should be 23. Okay, so, and work out the relative formula mass of water. How can you work it out? You know, water has 1 atom of hydrogen, sorry, 2 atoms of hydrogen and 1 atom of oxygen. So you have to get the relative atomic mass of hydrogen multiplied by 2 plus that of what oxygen. So your answer, you put it there, your answer you put it here. Then the answer, when you calculate the relative formula mass of sodium hydroxide, you put it here. It depends on your balance equation. You know, if it has 2 or 4 or 6 here, you have to multiply it through. So I hope you are getting what I'm trying to say. Then write these masses under the balance equation, which I just told you right now. When you write it, then you convert the relative mass to actual or reacting mass by putting in mass units. How can you change it to actual mass? Just like, let me show you the previous one. This is the relative mass, then this is the actual mass, because it has carried the units there. So when you're talking of actual or reacting mass, you are talking of adding the units like grams there. Okay, the final part is that you can now calculate what mass of hydrogen gas produced, just like we calculate the mass of carbon produced at the other side. So follow that procedure and do it. Chemists often need to know how much of substance has been formed or used up during a chemical reaction. To solve this problem, they need a way of counting atoms, ions, or molecules. And since they are tiny particles, very large number of particles are weighed out. This number is 6.02 times 10 raised to power 23 atoms, ion, or molecules, and it's called Avogadro's constant. You know, this Avogadro's constant was named after the Italian scientist called Amedeo Avogadro. So he was the one that gave us this calculation, you know, since they are very tiny, and when chemists want to carry out the experiment, they have to weigh them out, and after weighing them, all you need to do is to use the Avogadro's constant. An amount of substance containing 6.02 times 10 raised to power 23 particle is called a mole. So for instance, if you have sodium particle has 6.02 exponential 23. That's a mole of sodium as that constant. Don't forget. So calculating mole. How can you calculate mole? Chemists have found out by experiment that if you take the relative atomic mass of an element in grams. So for instance, we have for sodium, which is 23 grams. So for 23 grams of sodium, we contain 6.02 times 10 to power 23, which is called 1 mole of sodium atom. Okay, do you understand? So under calculating moles now, the first one we are going to look at is moles and elements. So for example, the relative atomic mass, which is represented by AR subscript R, of iron is 56. That's relative atomic mass of iron, 56. So 1 mole of iron is 56, just like the way I just explained here. So 1 mole of iron is 56 grams. Therefore, 56 grams of iron contains 6.02 times 10 raised to power 23 atoms. Do you understand? So always know that when you are talking of relative atomic mass, it carries no units. But when you are talking of reacting mass or actual mass, there's always units there. So the mass of a substance present in any number of mole can be calculated using the relationship. So mass in grams equals to number of moles times mass of 1 mole of that element. As you can see, mass of 1 mole of iron, for instance, is 56 grams. Okay? So when you want to calculate mass in grams at any point in time, you use this relationship. Okay? Don't forget, that's number of moles times mass of 1 mole of the element you are talking about. So example 1 now. Calculate the mass of 2 moles of iron. And B says calculate the mass of 0.25 moles of iron. Given the atomic relative atomic mass, which is AR of iron, which is Fe, don't forget that's the symbol for iron, equals to 56. So how can you do that? This is my solution right here. Mass of 2 moles of iron equals to number of moles times relative atomic mass, or you can call it number of 1 mole of iron. Okay, so definitely your number of mole is what you are given to be 2 moles. Then relative atomic mass is given to, at times if it's not given, you always have it in your periodic table. So it's 56. So you say 2 multiplied by 56 will give you 112 grams. So the B part, we have to calculate the mass of 0.2 mole of iron. Don't forget the formula. Mass in grams equals to number of moles times, okay, there should be multiplication sign here, times relative atomic mass, which is AR. So 0.25 times 56 will give you 14 grams. So if we know the mass of element, then it is possible to calculate the number of moles of that element using this relationship. Okay, this is another relationship. Let's highlight it. Okay, to calculate number of moles equals to mass of the element over mass of 1 mole of that element. Do you understand? Mass of 1 mole of that element, in some textbook you see it as what? You see it as relative atomic mass, or some can call it molar mass, as the case may be. So example 2, calculate the number of moles of aluminium present in 108 grams. Okay, that's the gram. You have been given grams, you have to calculate mole. So this is it right here. Number of moles of aluminium equals to mass of aluminium over mass of 1 mole of aluminium. Mass of 1 mole of aluminium is given to be 27, sorry. So when you have to calculate the number of mole, you use mass over mass of 1 mole. Mass is being given here, which is 108 grams divided by 27 grams will give you 4 moles. Then the second one, you have been given 13.5 grams. So you know G will cancel G, so that's why I didn't put it this time around. 13.5 divided by the mass of 1 mole of aluminium, which is 27, will give us 0.5 moles. Okay, so the second one we are going to calculate under reacting masses is to know about the moles and compounds. You know, the first one we did is we are under the subheading moles and elements. Let's see that. Okay, calculating mole. The first one we did under calculation of mole is moles and element. That's how to calculate the mass and the mole. Okay, we move to the second one, which is moles and compounds. So the idea of mole can be used not only with elements and atom, but also with compounds. I just gave you this. What is the mass of 1 mole of water molecule? Okay, mass of 1 mole of water molecule. You know, on a normal day we are being given mass of 1 mole of hydrogen, which is the relative atomic mass, and we can be given mass of 1 mole of oxygen, which can be 16 grams, right? Don't forget, just like the one we just did right now. So the relative atomic mass of hydrogen is 1. Then relative atomic mass of oxygen is given to be 16. When you do that, you have to do 2 times 1, because you only have 1 times 2. You have 2 atoms of hydrogen, and relative atomic mass of hydrogen is 1. That gives you 2. 2 plus 16. You only have 1 atom of oxygen in water molecule. So 1 times 16 will give you, adding the two together will give you 18. That's the mass of 1 mole of water. So the mass of 1 mole of a compound is called its molar mass. Don't forget that. That's different between mass of 1 mole of elements, which is reacting mass. Mass of 1 mole of compound is molar mass. If you write the molar mass of a compound without any unit, then it is relative formula mass. But if you put the units there, that means you are referring to relative molecular mass. That's MR. Okay? So examples. These are the examples. We have example 1. So you have to calculate the mass of 1 mole of ethanol, and B, relative formula mass RFM of ethanol. Okay? Mass of 1 mole, how to calculate it? This is how to calculate. Just work out the number of that atom times relative atomic mass. We give you the mass, then you add everything together for the compound. We give you the mass of 1 mole of that compound, okay, which is ethanol. Okay, the second one, if you just write it without putting the units, is known as relative formula mass. Can you now differentiate between the two? So mass of a compound equals to number of mole of compound times mass of 1 mole of that compound, just like we did for the elements part. This is compound part. So number of mole, you can calculate the number of mole, you can calculate the number, the mass of the compound, you can calculate the number of mole of the compound using all these relationships given to you. Okay. Okay, there's one here, there's another one here. This for when you want to calculate the number of mole of that compound. But if you want to calculate the mass of that compound, you use this formula. So example, here are the examples. Example 2, calculate the number of moles of magnesium oxide. Magnesium oxide, that's MgO, in 80 grams. You have been given mass here, so you have to calculate the mole. So you use the first relationship. Okay, you use this first one. Okay, so solution. The first thing you have to do is that you have to calculate the mass of this compound, the number of mole of magnesium oxide. So the first thing, 1 mole of magnesium oxide contains 1 mole of magnesium atom and 1 mole of oxygen atom. So when you add them together, the mass of 1 mole of magnesium oxide will give you this. That's mass. You have to calculate the mole. You know the mass, then you have to get the equation, the relationship to calculate. So this number of mole of magnesium oxide in 80 grams. So your 80 grams comes to the top, and the mass you just calculated come below. So you have 80 divided by 40 will give you 2 moles of magnesium oxide. Same thing with when you have 10 grams of that magnesium oxide. So your 10 divided by that. So mole and gases. When you talk of mole and gases, many substances exist as gas. If we want to find the number of mole of gas, we can do this by measuring volume rather than mass. So when you are talking of mole of gas, you talk about volume because they are not solid. Okay, so chemists have shown by experiment that 1 mole of any gas occupies volume approximately 24 cubic decimeter at room temperature and pressure. That's RTP, room temperature and pressure. The quantity is also known as mole gas volume, which is represented by Vm. So this is the relationship. Number of mole of gas equals to volume of the gas in cubic decimeter at room temperature divided by 24 decimeter cube. okay? Or you use it this way. If you want to get the volume, you can interchange it and make volume the subject of the formula. So for this example, calculate the number of moles of ammonia gas in volume of 72 decimeter cube of gas measured at room temperature. So number of mole of gas in this situation is ammonia equals to volume of ammonia divided by the what? The molar volume, which is 24 dm cube. So your answer will give you 3 moles. So the moles, the volume occupied by 1 mole of any gas must contain this. The idea was also first put forward by Avogadro, okay? And the law states equal volume of all gases measured at same temperature and pressure must contain the same number of molecules. So molecule and solution, moles and solutions. So if you want to calculate mole, chemists need to know the concentration of solution. Sometimes you measure it in gram per dm cube, you measure it in mole per dm cube. So a molar solution, a molar solution is produced when 1 mole of substance is dissolved in water and the solution is made up to 1 decimeter cube, or you call it 1000 centimeter cube. That's, you add more water to make it up to that mark. As a chemist, you do not always need to make up such large volume of solution. A simple method of calculating the concentration is by using this method. So instead of putting excess water, you can always calculate your concentration using this formula. Okay, you can calculate concentration in mole per dm cube using this formula, number of moles divided by volume in dm cube. So this is the example. By using that formula, we are able to get the mass, or calculate 1 mole of sodium hydroxide contain 1 mole of sodium, 1 mole of oxygen, and 1 mole of hydrogen, which we get to be 40 grams. Then we divide it by the mass given to us, which is 10 grams of solid sodium. Okay, so that will give you the number of mole of sodium hydroxide in 10 grams. Same thing, if you have been given in cm cube, you have to convert it to dm cube. So your conversion can be done by dividing by 1000. So if you want to get the concentration, you know the number of moles was the one we got initially. To get your concentration now, you use this relationship. Concentration of sodium solution equals to number of moles of sodium hydroxide divided by volume of 1 mole of sodium hydroxide. That will give us 1 mole per dm cube. So here are some few examples there for you to play around with. This is another one. This is the second one. Here you can always calculate the number of moles. Okay, you know, initially we make our concentration to be subject of the formula. Now number of mole is the subject of the formula. So you can calculate depending on the parameter given to you. So this is the answer for the question, which is 56 grams, because it's mass of that compound, which is potassium hydroxide that we got. So class drill, I want you to lay your hands on all these questions, following all the examples I've given you. You can easily do them. Okay, and for more exercises and explanation, you can check up your new school chemistry, check up your essential chemistry, IGCSE chemistry for more exercises and explanation. Stay safe and have a great day.